Hi everybody, welcome back.
Hey guys.
We are ready to talk about some ellipses.
Yeah.
So before you've done this video, you should have done an exploration.
Right.
In fact, it even says, if you didn't do the exploration, to stop.
Stop.
Do the exploration.
And then come back to us.
All right.
There's this guy right here.
Oh.
All right, so let's review real quick what you should have already picked up from the exploration.
Okay.
All right, so Ms. Cofield, what do you notice about these diagrams, these ellipses?
All right, so these ellipses, let's see. Letter A goes up and down. It's maybe taller, vertical.
Vertical.
Letter B is bigger side to side, horizontal.
Okay, so what about that as applied to, when we look at the equations, do you notice any type of relationship that?
Okay, well, the only numbers I see are a 36 and a 9, and I know 36 is bigger than 9.
Okay.
So, hey, the 36 is under the Y.
Oh.
Does that have something to do with it?
Well, Y typically represents our vertical.
That's our up and down axis.
Okay.
So since the 36 is under the Y, A is vertical.
Yes.
Oh, that works. Look, if the 36 is under the X, then it's horizontal.
All right.
Okay.
Let's get a little more specific.
Well, I also noticed that when I go in the X direction here, I get a 3 units.
Yes.
And when I go in the Y direction here, I get 6 units. Does that have something to do with it? And here I have 6 units and 3 units.
All right. Well, it's not a coincidence that when we look at our numbers in the denominator, taking the square root of each of those values.
Oh, square root of 9 is 3. Square root of 6 is 36. Love it.
Okay.
Okay.
And lastly, what about the fact that we have two of these, each of these examples are centered at the origin?
Okay, so does every ellipse have to be at the origin?
Not at all. We can
Not
have
at
ellipses anywhere on the graph.
Okay, so when we did circles, we did like x minus h squared and we did y minus k squared. Could we do that with an ellipse?
Exactly the same.
Okay.
Well done.
Very good. So let's get into the actual geometric definition of what an ellipse is. This is just some visual stuff. This is what we need to graph it. It's what we're going to remember.
Yep.
But what is an ellipse?
Where does it come from?
Okay. You want to
You're
switch
in?
me?
Yep,
I'm in.
let's switch.
All right, so the actual geometric definition for an ellipse is the set of all points in a plane whose sum of the distance from two fixed points is constant.
Okay.
So we're going to call those two fixed points. Now, when we had a parabola, we called the fixed point
Our focus.
our focus, but I have two of them, so I need the plural of focus, which is the weirdest word you've ever heard in your life. It's called a foci.
Foci. Not focuses, foci.
Right. Not right.
Not foci. Exactly.
Yeah, I don't usually call them foci. All right, we're going to leave those blanks for just a second, and let's see if we can see this definition in action.
Okay.
Okay, so it's got the same definition here. We found this little applet, and if we start drawing, notice that wherever the point P is, the distance, the blue distance to F1 and the blue distance to F2 is the sum of those distances. Is constant. So imagine it like 2 nails and a piece of string in between them.
And the string's kind of sagging.
The string is sagging, definitely.
Okay.
And if you pull the string tight and took a pencil and started drawing, this is what would happen.
Okay.
So the string length never changes.
Right.
But the actual distances from P to F1 and P to F2, those are changing.
They are changing.
But their sum is always the same. And if you let it go all the way, obviously, then you're going to get a distance of the blue string of 6, according to this picture.
Okay.
Now, the other thing we can do is we can look at this in a vertical direction.
All right.
So if we draw it in the vertical direction,
Same definition, really.
and I have no idea why one went clockwise and one went counter. That has nothing to do with it.
Just go with it.
But the same definition applies. No matter where P is, the distance from P to F1 plus the distance from P to F2 is constant.
Same. Cool.
You like?
I love it.
Okay, well, we can't watch this all day. We got to do some actual pre-calculus.
Let's get into the good stuff then.
Make that go away. Okay,
right.
So a couple of things that are going to be true for both of the equations we're going to talk about here in a minute.
Okay.
We're going to talk about a relationship between an A, a B, and a C. And what we need you to know and memorize is A is always bigger than B, and B is always bigger than 0.
Okay.
So A and B are positive. Okay. We can also talk about a C value. And for right now, just go with us on this, okay? It's straight up Pythagorean theorem. Okay, we'll show you in class why that works.
And just to be clear, we're not writing Pythagorean theorem wrong. We're going to apply it to our shapes here in just a second.
Correct.
Yeah.
Correct, that's true. All right, so the major axis, when I was talking about the exploration, in a vertical ellipse, the major axis would go up and down. It's the big one, okay? It is going to have a length of 2a, and it's going to have the center of the ellipse, the vertices, which are different than a vertex of a parabola, okay? And the two foci, which made our definition.
Gotcha.
The minor axis is going to have a length of 2b, and the minor axis and the major axis have to be perpendicular.
Okay.
So if the major axis goes this way,
Right.
the minor would go that way, and there's your ellipse. Use your imagination.
I didn't know you were an artist.
Me either, because I'm not.
Well done.
All right, so this is the diagram you see on your page.
Okay.
So let's talk about what we know. Well, we know that this dot right here is our
center.
Center, and our center is always
HK.
HK. Now notice for a parabola we called it a vertex, but for a circle, which is a special ellipse, we called it a center.
Yes.
Because I messed that up earlier. Okay, so our definition says that the distance to two fixed points, when I add those distances, I get a constant. Right. So this is going to be my D1, and that's going to be my D2, which makes this my F1, my first focus, and this is my F2, my second focus.
Gotcha.
Okay. Now, new rule: the focus is always C units away from the center.
So there's that C value. Okay.
So if I'm vertically up and down, my vertical part of my coordinate should be changing.
Okay.
And for my foci plural, I'm going to have H comma K minus C.
Okay.
And I'm going to have H comma K plus C.
2 points.
2 points.
Gotcha.
F1 and F2. And honestly, we won't make you label them F1 and F2. Just write them both down.
Okay.
Okay. So we got our focus. We got our two distances. What else? Well, we know from the exploration that this distance right here is longer in a vertical ellipse.
Yes.
So that's our major axis, and that has a distance of 2a.
Okay.
If I go from the center up to the top, that is a vertex.
Okay.
And if I go from the center down to the bottom on a vertical ellipse, that is a vertex. So again, we got a vertex 1 and a vertex 2. Again, the y coordinate is changing, only this time it's changing by a.
Right.
Okay, so we're going to have h comma K plus A, and H comma K minus A. Those are ordered pairs. Again, don't just memorize, think about a picture.
Right.
All right, so what have we forgotten?
Well, we've gotten the 2A, but there's that B value, and how does that apply to our picture?
Right, so on our graphs that we were doing on the exploration, or taking a look at on the exploration, the opposite direction was the B. Now my picture is getting a little messy at this point, but I'll tell you, if I take the furthest point here and the furthest point there,
subtracting them.
and I subtract them, that is my 2b value. So we need a name for these extra dots over here, and all the books we've come up with have called them co-vertices. They're with the vertices. But the co-vertices are weird because they go the other direction. So if the vertices and the foci were changed by A and C and they were up and down, so they changed the y coordinate, then the co-vertices are going to change
horizontal.
Yeah.
And we can still compare them with the center to come up with a good representation of the points.
Right, right. And our center was HK. So we're going to have H plus A, B.
B.
That's a B.
That's a B.
And H minus B.
Y values stay the same. You're on a horizontal line.
Okay, so this is weird, and it's like, what's changing? Okay, well, in a vertical ellipse, the vertical coordinates change on a vertex, and the vertical coordinates change on a focus, on the foci, both of them. And the co-vertices are just the opposite direction.
There it is.
All right, so that's our vertical ellipse.
Okay.
We should be able to now run through the same definitions on the horizontal ellipse. Now notice on your paper, the horizontal column is in the middle on your paper, but we couldn't fit it on the board. So.
All right, well let's start off let's just run through this real quick. We have the same definition for an ellipse, D1, D2.
Yep, we do.
And we also have a center, that doesn't change, HK.
Yep. And we should point out, because I forgot to point this out on my problem, the equation, oops. Notice on your equation, your A value, which is bigger, is underneath your X.
Right.
On my equation, the A value was underneath the Y because it was vertical.
And that's a direct way to decide if you're dealing with a vertical or horizontal.
Right, right.
All right, and then so from there, how about if we talk about the foci?
The foci. That makes sense because the foci are what makes up those distances.
All right, and what was that again that you said about the distance between the foci?
Right, the center to the focus is C.
Okay.
Center to a focus is C. And I honestly remember it because it's foci. It has a C in it.
That works for me.
All right, so we're going left and right this time.
Okay.
So what's changing for our
so let's start with just a foci here on this one, right? So left to right means that I need to, from the center I go minus C, my horizontal stays the same.
Perfect.
And then the other direction at C, I'm on the horizontal line, so my Y value stays the same.
Right, right. So the k's are the same because up and down. Perfect.
Okay.
Okay.
And how about if we talk about, again, this whole thing here. Now, last time you had a b value for your horizontal, but we're going to call this 2a.
Right, because again, your a value is under your x.
Okay.
The major axis is the longer distance, and obviously when we're looking at a horizontal, the longer distance is going that way.
Gotcha.
Okay, so that's 2a. So those ends of that major axis must be our vertices?
Yes. So v1, v2.
Okay.
And again, we can now relate those using a in the center to come up with our vertices.
Okay.
So how about h minus a,
Love it.
k, and then h plus a.
And again, the k's are staying the same. Perfect.
Okay.
So now we're ready for the weird ones that go the other direction.
The weird ones that go the other direction. So we're talking over here
Yeah.
and here. How about with respect to what's happening out to the side?
There we go.
So what's this length going to be?
Well, that's the other direction. That's got to be 2b.
2b. All
Or
right.
not to be. Sorry, I
That was
couldn't
bad.
help it.
So bad.
This is we can't do English in our. Never mind.
All right, so help me out here. What
Okay.
are we going to
So
do?
now the h is going to stay the same. So we're going to have h comma.
Okay.
But this time, notice we're going up and down, so it's going to be k plus b.
All
And k
right.
minus b.
There you go.
So again, on a horizontal ellipse,
Please.
the horizontal values of the vertices and the
Right.
horizontal values of the foci will be changing.
Can you label those co-vertices for me real quick? I forgot.
Oh, yeah.
Sorry about that. That's on me.
That's all right.
Miss
I forgot
Coco's
to talk
got
about my equations. So.
She's got my back.
Co-vertices. I'm not sure I labeled them on mine either.
Oh, okay. There we are.
So co-vertices going the other way.
Awesome.
Again, you're going to need to know those equations. They look just like a circle, but they're dividing different amounts in the x and y direction.
Right.
Okay, so first job of the day. Is it horizontal or is it vertical?
Well, we should be able to tell right from the equation, shouldn't we?
Absolutely.
Okay.
I see a 25. I know that's bigger than 6.
All right.
I know
16?
it's, thank you, bigger than 16.
Okay.
I know it's under the x. Ooh, look, they switched the order on us.
They did.
How mean was that? But why are they allowed to do that? Because this is adding.
Okay.
And the order of addition does not matter. So I care that the 25 is under the x. This is horizontal.
Horizontal. Good. Yes, it is. All right, so we're doing a horizontal, so, and we know the equation. What else can we pull from
Kind
that?
of doing this somehow.
Okay.
If you, it's not going to work if I try to connect it. Let's be real.
It looks
Okay.
good to me.
So I know that the horizontal underneath the x is
Yes.
a squared.
Okay.
So I can know right away that a is 5, the square root of 25.
Okay.
I know that the other direction is underneath the y,
Uh-huh.
and the square root of 16 is 4.
Okay.
All right. I also know that in a minute I'm going to need some foci, which means I'm going to need to talk about the relationship between a and b and c. I know that a squared equals b squared plus c squared because a is the
largest value.
A is the largest
root.
value. He's ruling the roost.
Yes.
Okay, so we're going to have 25 equals 16 plus c squared, a little bit of magic or arithmetic.
And we're in class, we're going to talk about a squared equals b squared plus c squared. We'll show you where
That's
comes
coming from.
Yeah.
Absolutely. Okay, but for now we're ready to talk about the center, and we have all the pieces we need.
Okay.
The center comes from h and k. H is the horizontal translation, which is the opposite of that number,
Oh, yeah, we've seen that before.
and k is the
Opposite.
vertical, -3.
So there's our center.
And I should probably label that center, because
Okay.
I forgot to write that word. All right, so then the vertices are going to be on a horizontal, a amount away from the center, left and right.
Okay.
So vertices, I'm just going to write it all backwards and mess y'all up. Okay, so the vertices are going to be a amount
Right.
away from this
center.
value.
Uh-huh.
So if I take 1 minus 5, I get -4.
Okay.
And if I take 1 plus 5, I get 6. The y values do not change.
-3, -3. All
Okay?
right.
Simple as that.
Yeah.
Okay, so back to our c value, which was our 3.
Uh-huh.
That is helping us with our foci.
Right.
So our foci, I'll write that one correctly too. Again, the comma,
I love it.
comma and an and. I'm getting excited here. Okay, so again, the horizontal number is changing by 3. So I'm going to have 1 minus 3, -2. 1 plus 3 is a 4. The y
Same.
values are not changing.
-3,
-3 and 3.
Okay.
Now, do I even need B? Technically, no. But what might be nice is for you to go ahead and graph all 5 of these dots and make sure that they all are in a horizontal line. Because if they're not, you did something wrong.
Yeah, and B did help us find C, didn't it?
B did help us find C.
So
And if they asked us to graph this, we would definitely need B to be able to figure out the co-vertices. And even if we don't write them, we will need those dots of the co-vertices on our graph. So they didn't ask for them, we didn't give them to them, but that information would be helpful in a graph.
Awesome.
Okay.
Looks good.
So what's next, Mr. Madsen?
Let's look at the next example here. So in this case, what do we got? So they don't give me an equation. In fact,
they're giving me the stuff.
They're giving me the stuff, so we're doing backwards of what we just saw. We're starting with the information, and our goal is to build the equation.
Okay, but which equation do we use?
Oh my goodness, where do we even start? Well, you know, when I get stuck, I like to draw a picture.
Oh, that's awesome.
Just to see what's cooking. So let's go graph what we know. How's that sound?
Sure, that sounds good. I'll help you out. The foci. We have a negative 2, 1.
Okay.
It's hard to see the board and draw on the board at the same time. We have a negative 2, 5. And again, these are little sketches, so they don't have to be perfect.
Right.
Well, right away, Mr. Madsen, if the foci, F1 and F2, are up and down.
Oh boy, you weren't kidding about being perfect. My
That's
goodness.
right. That's pretty good.
Okay.
If those are up and down.
Right there, I know that I'm doing the vertical.
Yay! Okay.
So while we're at it, let's go ahead and just graph the vertices in our picture as well.
Okay, so if I have the major axis endpoints, we know right away those are the vertices. And how about negative 2, negative 1?
Okay.
So that's a vertex. And negative 2, 7.
So 5 up 2 more?
Yep.
All right.
And again, that's just confirming this is definitely a vertical equation, a vertical ellipse. So if it's vertical, should we start off with like just writing the generic one?
All right, so let's go ahead and, let's get a scaffold. This is what we need to fill out. We
Okay.
got x minus h squared.
And that's going to be squared, yep.
And that's going to contain the b value because it's vertical, so
Right, so if
smaller.
it's vertical, the y is bigger. The y denominator is bigger, so the a goes under the y.
Yes, it does. And so our a is going to go here.
And it always equals 1.
Okay.
Did you notice that? Always equals 1.
All right.
Okay, so let's see, what do I know? Well, if I know the vertices.
Okay. So the differences of the y values of the vertices is going to be equivalent to 2a.
Okay.
How's that sound?
That sounds great. So the major axis is 2a.
All right.
Okay, so how about 7 minus a negative 1?
Thank you.
Oh, that's 8.
That's easy enough.
A is 2. A is 4. He said easy enough to
A
mess
is
me
4.
up. A is 4.
All
So we
right.
got A. We don't have anything to do horizontally, but we do have some foci. What do foci tell us again?
They relate to the c. Those two work together. So let's run this real quick. We know that 2c is equal to the differences between the foci.
Oh, okay.
So 2c is going to equal...
So it's almost kind of like an axis, but it's not called the axis because it doesn't go all the way to the edge.
Exactly.
Okay.
Exactly.
So 2c is going to equal 5 minus 1.
Okay.
So that's
I
4.
think
How
they
about c
can-
is 2?
I think they can handle that.
Yeah.
All
Okay,
right.
so we got A and C, but we don't have a B.
Gee
Oh,
whiz.
wait.
I wish there was an equation.
A squared equals B squared plus C squared.
Well, that works fine.
Okay, so A squared is 4. How about 16?
I didn't change color. I apologize.
No, you're right. But you get it right. 4 squared. There we
Okay.
go. D squared
Which we don't know.
and C squared would be 2 squared.
Okay, so I'm sure at the end of the day they can
Wait.
handle-
Mm-hmm.
Look at that.
2 squared.
Let's make that a squared.
See, we do that too, because 2 squared really is 4. All right, so 16 minus 4. How about 12 is B squared?
Thank you.
Now, do we have to square root that?
We don't. We're not.
Why not?
Because we're really just after the b squared in the equation. I think the little
Oh.
highlighter thing you do. I don't know.
There we go. We just need a B squared, and we already know B squared is 12. Cool.
All right.
So we need A and B and H and K.
Oh yeah, we haven't found the center. We need to figure out where the center is.
Oh, well, the center's right between the 2 vertices or right between the 2 foci.
Okay.
So if that's, let's see, that major axis was 8 units long, so 4 units away from the top vertex. We could just draw down on our picture. Right?
Okay. Right.
There we go.
About where are we at? Here.
Yeah. So if the top vertex is negative 2, 7, and I go
Okay.
down 4 units,
So negative 2, 7 down 4 puts us at, well, we're still at a negative 2.
yes.
And then what did you say? 7 down 4.
Yep.
So on a good day is that 3.
Yay!
All right.
So now we have our center, H and K.
Okay. Love it.
Switch color.
Let's put it all together.
I'm obsessed with the switching colors.
Hey, no, that's good.
Okay,
That's
so
good.
final answer.
It looks like a clown threw up, but it's good. Okay, final answer. X plus 2 quantity squared over the b squared value, which we know to be 12.
Oh, yeah, B. Okay.
And then we have y, and what was minus 3 quantity squared
Good. Remember that's
over
backwards.
the a value,
A was 4, so
So-
A squared.
16.
Awesome.
How's that look?
It's awesome.
All
The
right.
green would be your answer, even though the clown threw up.
All right. Okay.
Quit picking on me. If I wanted this treatment, I could talk to Mr. Leckie.
Fair
All right.
enough.
Okay, so last example, we're going to prove that the graph of this mess is an ellipse. Okay, we've done this like 3-4 times now.
Yeah.
We did it in 8.0
Right.
when we didn't even know what we were going for.
Right.
We did it again with parabolas. I think we even did completing the square with circles.
Yep.
So pause the video. It's
Right.
on you.
You know how to do this.
So we should have completed the square, and you probably got stuck right about here. And what we need to remember is that in Mr. Madsen's last equation, it equaled 1, which means we want our ellipses to equal 1. That is the transformational form of an ellipse. If you care, the book will call it a standard form, which I hate because when we did lines, standard forms didn't have any parentheses. So I call it the transformational form. I can see the transformation went right 1 down 2.
Yep.
But what I can't see is my stretching and shrinking. So now all I need to do is make it equal 1. I'm going to divide by 4, divide by 4, divide by 4. And I'm going to reduce this fraction into x minus 1 squared over 1. And then I'm going to leave the second one alone because there's nothing in the numerator to reduce. And then I got equals 1. So now my equation is pretty. All I got to do now is figure out what was it they asked for.
Okay. So we proved that it's an ellipse. Now we need to find the center and the foci.
Okay, so the center is going to be h comma k. That's easy enough.
Right.
Opposite of -1 and opposite of positive 2. There's my center.
Large values in the denominator below the y, so we know it's vertical.
Right. Oh, I was just going to say that. Good job. Vertical.
Excellent.
So if it's vertical, then the y coordinates are changing for our foci.
Right.
I'll get it right.
The y, yep.
So our foci are going to be 1 comma something and 1 comma something.
Okay.
Okay, sometimes it's easier just to leave the same stuff alone. Either do it at the beginning or do it at the end.
Right.
All right, so we're going to have -2. But the problem is the foci change by c.
Oh,
And since the foci change by c, I need to figure out what is c. So let me see if I can slide this down just a little bit. There we go. But what I do know is that a is the larger denominator.
Right.
So a is going to be
2.
And then b.
Is equal to 1.
And why is that 1, 1, and that one's 2? What just happened?
I know that a can't be 1 because a is always the larger of the two values, and so a is coming from the 4.
Right, and since I square rooted a 4 to get a 2, and when I square root of 1, it's still a 1.
It's still a 1.
Looks like I didn't do anything, but I did.
Right.
Now, keep in mind, and I'm just going to erase a little to make myself some more room over here.
Yeah.
Okay, so keep in mind, a squared equals b squared plus c squared.
Yes.
So a squared was 4. Oh, look, I didn't even have to square root it. B squared is 1. Work smarter, not harder,
That's right.
Rosefield. What am I doing? Okay, 3 squared. 3 equals c squared, so the square root of 3 is c. Ew, that's a yucky number. I think we did something wrong.
Oh, I must have messed up.
Get over it.
That's right.
So we have -2 plus the square root of 3.
Yep.
And we got -2 minus the square root of 3.
Home run.
And square root of 3 is just as friendly of a number as anybody else.
That's right.
Okay, I think that's it for ellipses. We'll show you that relationship between A, B, and C when you get to class, and we'll do some practice problems.
All right, guys.